Okay, this is about, as I've said, this is about exploring and analyzing the open transport data sets that are easily available to us in these days. And of course, it's not going to be exhaustive, even if I try to, what I'm trying to do is to give some examples so that we know where to look when we would like to find out more about our environment and the transport issues around us. So that's the goal. It's not like I can give an exhaustive list of all these different data sets. That's not the case, but I try to introduce them in a way such that it becomes more accessible. So, okay, let's get started. And then the overview of the session, I plan to not use up the whole 2 hours. I find that to be a bit too much for both the audience and myself, of course. So the first part, I will try to keep the time and finish before 10:45, and we will focus on this presentation, where I'll try to introduce some of the sources of open data, and then how do we obtain them, and how do they look like in general. And then very briefly, I will go through a few applications that I came across in these days. Yeah, you know, we all live in a pretty strange time these days with COVID and everything. And I will, for these applications, I'll focus on the later two, which is about COVID and mobility. And then this is actually demonstrated, the use of this data set was demonstrated by a blog post on the website of the Urban Big Data Center, written by our colleague. And then the other one would be a paper that is, that we revised, I think is quite close to publication. And then it will be about the shared bikes in Glasgow, and then the trip data that we use and how from there we turned it into a paper. So that's what we are going to do. And then after a short break, we will go into the practical session. And then, if you have RStudio, you are welcome to follow along. If you don't, it's still fine. Then I will share the script and the presentation afterwards. So, okay, let's get started. A little bit about me, not like not too much. I'm currently a research associate in transport analytics at the Urban Big Data Center of University of Glasgow. So during my PhD and after my PhD, what I'm interested in is mainly transport taxes, such as road pricing, and then optimal public transport supply, and also accessibility, which I'm currently working on. And a few publications that I had with my colleagues are also about these issues mainly. The first one is about rural area, whether it is our goal was to evaluate whether it is a good idea to have these kind of very expensive rail system in rural areas with very low density population, and then sometimes replacing it with buses is actually a better idea. And then the case study was from Sweden, because one of our co-authors is from Sweden, so we get access to the data. And then the other one, which is also using Swedish data, and then we evaluate whether buses and cyclists, who are hindering whom. It's very difficult to say, because if you imagine that, I think some drivers are pretty annoyed by cyclists. And then, but then in the case of buses in a city area, like the city center of Stockholm, when a bus line, they have to go to the bus stops and then stop at the bus stops. And what happened is that the cycling suddenly disappear. So that the cyclists will have to move around, if you see what I mean. They will have to switch to another lane, and then they will have to interfere the other traffic in the outer lanes. So that's the idea, and then we try to evaluate this interaction. And then in this paper, what we do is that we usually use more aggregate model, so that the key of whether these models work well or not would be to evaluate the interactions between different modes. So that's usually the key. How would one mode, like, okay, what if there is road pricing? How will the ridership of public transport react? So that's the key idea, the interaction between modes. And then why do I talk so much about this? Because it is actually related to the paper that I'm going to talk about a bit later, about the interaction between the subway system and the share bike system in Glasgow. So, okay, a bit about open data. Actually, yeah, it's just a very brief introduction to it. In the title of this session, I actually wrote open data, I think. But then you need to be really careful that not all of these are like open government license where you can pretty much, roughly speaking, you can reuse them, you can basically redistribute them most of the time. But then if you have to be really careful with the licensing terms when it comes to some of the data that is not necessarily having an open license. So yeah, you could see that many of them would be open government license later on. Oh, sorry. So I think that many of these data sources that we are going to talk about, it's usually quite straightforward that we know what they are. These tools, some are very straightforward, like Department for Transport for London. They have a very, very good page with many different data sets. And then for some of the city council portals that some of them I'm also going to talk more about in the second half of the session, is that sometimes you might need to register to get a key or a login name to use them, and it's not exactly that easy because you might not get it in time when you try to use the data, and then sometimes the site might not be working very well. So let's see how we get on with it today. I believe that we included our link for one of the API for the Glasgow City Council data, but then I found out that that link might not work. So let's see. And another very important source, of course, is the Urban Big Data Center collection of data that if you take a look, yeah, very briefly, and you can see that there are we acquire a pretty good collection of data, such as this CCTV data, where they process the image and the videos such that you could, if you specify the location, you could get the count of the pedestrian or cyclists or vehicles and so on. And some of the very new stuff other than that, related to transport, is this Halkett data set, which is mobile phone data and very comprehensive and pretty detailed whenever the user they use a certain app. Not a certain app, is the collection of apps that that the company works with, so that we could have the location of the users. And then, so this could be pretty useful in terms of mobility research. And yeah, you could go through this when you have when you have time and applied. And this is, many of them is not open license, but then of course you can apply to use them through Urban Big Data Center, and then be careful with the licensing terms and see what you can do with them. And also one thing that I found is GitHub. I usually, at first I wasn't realize, I know that GitHub exists, but then I find out that sometimes when you browse through GitHub, you find different packages and different scripts, and that led to some surprising discovery with data sets. That's my opinion. So you might look through that later. And then for the map data, Google Map, of course, they have a lot of different data that you could use, like distance matrices. You could specify the route, and you can calculate the travel time and report it in pretty much real time. But then you will have to be very careful, because you will have to enter your credit card in order to use their API, and then you would not want to request too much and then ending up having to pay a whole lot for that. And also OpenStreetMap, and yeah, that's also a very good source for things like points of interest and so on. And if you were from academia, or you were students, if I remember correctly, you can also register to use Digimap. So these kind of data sources, they could be real-time or historical. Historical is more simple. Most of the time, if you know it's historical, of course, they would just dump the data on the site, and then you can just click download and you get it. It's usually more straightforward. But then for real-time data, usually it's more complicated, because it gets updated a lot, like every minute or every 5 minutes. And if you want to get it for research purpose, then you will have to make use of some simple tools in order to just get these data over time. And how do we get it? Of course, yeah, when I was saying about historical data, most of the time you can download them. And then for the real-time ones, most of the time you will need to make use of API, or if you are familiar with it, you can do some web scraping. So in the second half of the session, we'll try to use RStudio to get access to some of these real-time data, like every 5 minutes, and what is the count of traffic in certain locations. Okay, so yeah, cars, yeah, we briefly talked about this, the traffic count. We have it, the reason that I put Brussels here is because I planned to use the Glasgow traffic counts and the data sets as a demonstration, but then I found out that you might not be able to get the API key in time. So I think that to avoid that issue, to avoid registration, we could try the Brussels one later, because it doesn't require a key. You can just request it using a very like 2 lines in R, and then you get the count. Okay, and also this is also real time. Obviously, you would want to know about parking availability, and you want to know it to be updated in real time. Sometimes traffic events might also be interesting, and you might want to know what happened with a certain part of the motorway, what happened with that part, if there were accidents or some sort of closure that we might want to know about. And then the next thing would be some variable message system. That's just the message box that you can see when you are on a motorway. So yeah, we could when we try to look at them in the second half of the session, then we could also show some of these messages. What do they say? Like over time, during COVID time, they ask you to stay safe and stay home and so on. And one thing that I was, actually there's a picture of the variable message sign here. You can see, you can specify the location, and then you get a message about the roadwork at a certain point. And another thing that I have been quite interested in are the potholes, and yeah, I find that quite interesting. Fix My Street is also is actually not only about potholes. But then I actually laughed a bit when I see this one. You can see that people are reporting potholes because they are so pissed off, and then they report these kind of dangerous potholes, and then they take pictures of it. And then if you read it carefully, if you try to read this, you can even see that update. I thought that it would be from the city council or something, but no, it's actually from another user saying that not a chance that they repair it or deal with it. So it has been quite interesting. So if you are looking at a road network, I suppose that this information about the quality of the road would also be quite useful. So of course, accidents reports that is also a part of the picture. And yeah, then we move on to another mode with bikes and the pedestrians. Then we have this, again, is from UBDC. I think we saw that when I was showing the website of UBDC, where you have this API that you can request the count of pedestrian and other vehicles or cyclists over a certain period of time. And yeah, you could also go over with cycling infrastructure. These are links, but then I don't think I will show every one of them, but I'll share it later. And then one focus that we will be talking about in the second half of this session, and also it will be related to one of my papers, is that the use of shared bike data. And there are usually, if you go on a site of a share bike company about their data sets, there would be two different things. Usually they have this data dump where they have a lot of files about the details of every trip, when a bike is unlocked and when it is returned and so on. So I find this to be the most useful one, and then we make use of this in one of our papers. And for the API for Share Bike is actually quite easy to use. And if you are interested in the availability of this kind of bike, or how these bikes are arranged or moved by the company, or how the demand is different, then this is also quite useful. But then from this API, as you can see later, when we actually tried it, we could see the location and the coordinates of the bike station, and also how many bikes are there or how many spaces are there, instead of all the trip information from the file that you can download as data dump. So I find that is also an interesting point if you are interested in bike sharing. Okay, if we look at it from a different point of view, like, okay, this is in Edinburgh, and then you can see that you can download the trip data, and this is what I was referring as data dump. And then yeah, you can see you have all this information like start station, description, coordinates, and then the time, and so on. So you have very detailed information of each trip. And then if you go on, that's it. That's what you get. And then you also get the real-time data about the station availability that I was referring to. But then if you click on some of the US bike share data, I think it's also quite interesting, because yeah, it looks very similar. But then what strikes me is that they usually provide more information. I guess this is partly due to GDPR. That's my guess. I haven't really looked into it, but then for the ones outside Europe, you usually get something more in more detail, such as the user type, even the birth year, and the gender of the user. So yeah, so it depends on what you need in your research, but then yeah, that's a point that is worth noting, I guess. So public transport is actually, for me, is a bit painful because it's not very easy to obtain data, and they are mostly not shared among the public. And most of the time you will need to obtain them directly from the company. And then as you could see, if they are in a they are not in a working relationship with you as a researcher, or if you are not a consultant working for them, then it's not very easy to get sensitive information. But then one thing that is open is at least the timetable, or even most of the time, if most of the time they will share the real-time location of their vehicles. So that's also possible. But then, and for the prices, yeah, fares, then it's a bit easier because you can basically scrape them directly from the web. Or in the case of rail here, Rail Delivery Group, you can also register and get information of this from them. So I think that this is the most constrained area in terms of getting data that is available to the public. We don't know that much about them, especially in this country with the market structure of the operators. That's pretty unfortunate because it's a big piece of missing puzzle, I would say. Someone said freight data is even more constrained. Yeah, yeah, that's even more unfortunate. Okay, yeah, okay, so I'm just thinking that, okay, with Glasgow, with these kind of data, then if we put them all together, we have different modes, and then of course it's not like a complete picture, but we have a much better picture if we look at these, if we gather them together and try to build models, including different modes. And for the mobile phone data, yeah, that's again, I highlighted it because UBDC, they are having this mobile phone data set. So yeah, perhaps if you are interested, just check it out and apply to use some. So the first, yeah, I will move on to some of the applications. One thing that I found about this type of the data available to the public is this thing I found during times of lockdown. I read an article, I think it was on Financial Times, and they did some, or The Economist, both of them did something pretty similar. They tried to compare the hotspots during lockdown and so on. It was a very early time of the lockdown, like last year in March or so. So there is actually this, when you search for a place on Google, for example, this is Glasgow Botanic Gardens, which is like 5 minutes from where I am now. And what you will get is that you get these popular times and you see whether there are, what time of this place is usually the busier times. And then what I did is that I also found something pretty interesting, which is a GitHub repository, which yeah, I didn't write it, that enable us to download this data in real time, so we get an idea about how busy a certain location is, as long as you can get the location ID. Yeah, the details is on the GitHub. It's the link here. I'll just press it. It's something that look like this. Yeah. So as long as you can get, yeah, you again, you need this API key to set it up. But then what happened is that if you get at the ID of the park, then you could do something that I was trying. Yeah, I got a list of ID of some parks, and I tried to compare them to see whether they become more popular during lockdown or not. And I find that it's actually quite interesting, because you could see that on the left, there is this one with the blue bars actually represents the regular, during normal times, how popular the park is. And then, yeah, the two lines represent the lockdown. So you see that some parks are actually less popular, and some of them are more popular during the lockdown. And then when I look at, I don't know Glasgow that well. I wasn't here for that long. But then the interesting thing is that if you okay, so where was my file? Yeah, but then never mind. Yeah, I was just talking about that. Okay, I could do that without showing that actually. So the parks, about the parks, which has this pattern, whenever they become less popular during the lockdown, they are actually the city center smaller parks, while the ones that are becoming more popular are actually on the peripheral area of the city. So I found that to be quite interesting, although it seems to be a pretty trivial observation. But then, yeah, you can see all sorts of things when you try to carry out this type of analysis. So that's the first one. And then this one, we will also get into more detail a bit later, although not using exactly the API of the Scoot data in Glasgow in the second half of the session, where I try to, yeah, if you read the map carefully, you could see that, okay, the green icons, it says, this one, it says check your mirrors when moving between lanes. So this is actually a map showing all the, yeah, if you read it on the legend, this one shows the variable message system, the messages. Yeah, here you also have look once, look twice, think bike, and so on. And then in the middle, the orange ones are also are actually about parking availability, and then the blue ones are the count locations of traffic. So these type of things, you could see that if we get hold of the real-time data, we can easily visualize them and then download these data for research purposes. And the third one is actually about the paper that I'm going to discuss, and I'm trying to introduce it very briefly so that we could go through some of the steps later in the second part of the session. So this paper is about examining the effects of temporary subway closure on cycling in Glasgow. So we used this bike sharing data from Next Bike, which operates in Glasgow. And then what we want to evaluate is there was a temporary closure of over 1 month in 2016 for the whole subway system. So that's quite amazing to me, because I rarely heard of anything like that. You close a whole system for for a whole month for renovation and then upgrading and so on. And then since the system is quite small, and then the distances between the stations, the subway stations, are actually pretty short. So I was thinking that maybe people will replace these subway trips with cycling trips. So that's the idea. And then that's why we evaluated using the bike sharing data. So yeah, again, this is the same objective as I was saying about some of my previous work. So to study how different modes interact. When there is this disruption of public transport mode, subway in this case, how will people react in terms of their cycling behavior? That's the idea. So yeah, very briefly, then yeah, we narrowed down the study period to here because yeah, you have this red segment, which is the actual suspension from July to sometime in August. And then these phases is just the introduction of the bike stations, the number of bike stations that Nextbike is having during that time. So you have, yeah, I exclude some of it because yeah, the growing number of bike stations might have affect the result. So yeah, that's the idea. We study the part within the month. And then, yeah, as I've said, the system is actually pretty small. So yeah, this is just to show that it's like, yeah, these stations is just if you are not familiar with the system, I find it very amusing when I first came to Glasgow because it's just a circle. And then you go clockwise or you go anti-clockwise. That's it. You can never get lost. And it's a very, very short. So that's why I think that it is possible that it can be substitutable with bike rides. So what is this about? It's not super clear, but then yeah, you can see the orange ones are the subway stations, and then these little dots are the bike stations. So the idea is that, of course, we try to compare the time during the suspension and after the suspension to before the suspension. So you could see how behavior change. But then that might be problematic because we do not make use of most of our information. In terms of bike rides, we know the starting station, we know the ending station, so we have more information than that. So what we have done is that we draw this buffer area where it's like a catchment area, where we think that, okay, if these bike stations are inside this treatment area, this catchment area, then we will call these bike stations the treatment stations. The other ones are the control stations, like these ones that are very far away from the subway system, the subway stations. So that the idea is that these stations, the trips of them are affected by the subway suspension, while these are not. So we get another comparison. Instead of only over time, we compare the suspension and without the suspension. So that's the idea. So yeah, of course, that it relates to some of the existing studies, but then again, I would not go into detail, but that's it's just that if you are already familiar with the terms, then you would know this is only about the interactions between the different modes. So simply, to put it very simply, is just that now we are suspending the service of subway. That means it's like you can think about it as an increase in the full cost of taking a subway trip. And then with this change, how would it affect the quantity of trips in bike sharing? So that's the idea. And then if we put together these type of measures, then we could compare these with different studies that are doing similar things. That's the idea. Yeah, and then sometimes if you go into the literature, it's not a new thing that people keep wanting to find out about the substitutability or complementarity of trips. Like, they study Uber as a complement or as a substitute of other trips. And also, it is possible when you look at it about rail or bus and so on. And because if you see bike sharing as a substitute, that means it replaces the trip. But then if it is as a complement, then it is like the second case here, where it is a first mile, last mile facilitator, which means that you ride the bike to the, let's say, the rail station, and then you take a rail trip. So that's the idea. And then, of course, this might look a bit intimidating, and then if you are not used to this, but then the idea, as I've said, is that you are making two comparisons. One is between the time period where the suspension is there. And since we would want to see whether people are coming back to if, let's say, with the suspension, they want to ride the bikes. And afterwards, do they still want to keep on riding bikes? Or when the subway is back, they will switch right back to ride in subway. So that's the idea. So that's why there are the post-suspension period also. And then another comparison would be the treatment station and the control station, the bike stations that I was talking about. So when you do the analysis, you create different dummy variables and so on. And I won't go into details, but then if you follow the study, then you would know that after some basic cleaning of the data, you would want to cut some of the trips that are perhaps way too long to be covered. Because we are talking about replacing subway trips, so it won't make sense if they are riding the bike for 5 hours, and I cannot really claim that it is a commuting trip. So that's why some of the trips are removed, and you can see that the percentage is not that much if you draw the cutoff around 150 minutes or something like that. That's pretty useful in looking at the whole picture and deciding where you want to make the cutoff. And then also you have this is a diagram for the justification of using this type of model where I have the treatment and the control and so on. You can see that visually, the treatment group and the control group do behave quite differently during the suspension period. So I think that's quite a strong visual evidence for that. So the hypothesis, to say it simply, is that the Glasgow subway station is in a dense city area. We would expect that these two modes, the bike sharing mode and the subway, would be substitutes. So that when you evaluate it and when you estimate the model, the coefficient would be positive, the representing coefficient of interest. So I wouldn't go back to the notation, but then the findings brings us that actually, despite the system being pretty small, we really get more incoming and more outgoing bike trips when compared to the control group, and also when compared to the other times that is without the suspension. So that kind of strengthened our argument for our initial anticipation for the results. And then, although the number doesn't look too large, it looks like, okay, it's not a large number of trips. But then actually the system, both the subway system and the bike sharing system are not that big, so that it already represents around a 20% increase when you compare it. So it's actually quite big. But then, of course, some of them, after the resumption of the subway service, they disappear again, and then they go back to ride the subway. So after this, then we would see that with these findings, if we convert it, if you remember that earlier, I brought out this term about diversion factor, is just that when we have one fewer subway trips, like people are shifting away from subway, how many of them ended up riding a share bike? It will be very, very small, less than 0.05, which is the suggested value in some of the literature. But then, of course, these could be due to many, many reasons. But then we find a much smaller value than this. So yeah, I think this will end the first half, and then the second half we will get more hands-on with trying to obtain some of the data and do something with it in the second half. And then I will also try to show how we start from there, and then what could be done potentially with the data set to create something pretty similar to what I have just shown you. Although I couldn't really use the next bike trip data because it's obtained from the company and it's not on their website right now. But then we would be using something that is freely available in the session. So this is it, and yeah, I will come back to the second half. But then shall I answer some questions?
So
yeah,
thank you for your talk. I think the very first question, which is not a question rather than a comment, was about Norway system for a public transport, public information portal.
It's compulsory.
Which I think
it's cool. Yeah, yeah. It's so in Norway, it's a compulsory sharing all the information of every stop and timetable for public transport. That's pretty cool. I think that if I understand correctly, that we are also going towards that direction, but we are not there yet, from what I understand.
Yeah, I would encourage everybody to look in a chat room. There is a useful link pointing to English development pages. So if anybody is interested, so public information portal for Norway, which is based on OpenTripPlanner. Right, let's move to the other question. Question from Alan. How are you accounting for the other counterfacts which have affected the treatment group?
I think that there are, of course, there are a lot of things that we couldn't really take into account, but then the model we use at first thing, it was fixed. We try to take into the differences of station in terms of using the fixed, including the fixed effects. That's the first thing for different stations. And also we included the weather data and then some other variables. And yeah, and at the same time, yeah, of course, it won't be perfect, but we try to make sure that at the same time, there's no particular things that is particularly affecting the treatment group only. Yeah, so I think that's probably a simplification, but then that was the best that we could do from that simple model and then the information that we had. So it was a panel fixed effect and also the other covariates, and trying to take out the period. Yeah, as we have, I have shown the diagram with different phases. So we try to identify, we try to cut out the time period where there are a lot of things happening with stations too, because there had been an increase in the number of stations. So that was what we were trying to do. I hope that answered the questions partly, at least. Okay, sharing the presentation as a PDF. Yes, I will. Actually, the scripts that we are going to use and the presentation will be shared but I'm not sure it will be my personal GitHub or the Urban Data Center GitHub, and I will try to find it out. And then, yeah, when we share this recording, it will also be available.
I think, can I just quickly jump with a comment? In previous session, I think every registered participant received a link to a recording and supporting materials of the Guarani. So I think it's.
Oh, I see. Oh, that is cool. That is cool. I haven't uploaded it yet, but then yeah, I will tidy it up after today and then we get it.
So yeah, just to answer the question, it would be shared in some form.
Yeah.
To the registered participants. Thank you.
Yeah, if you want to follow along for some of the steps, I'm trying to, yeah, do you see my screen with the RStudio?
Yes.
Brilliant. So I think that the best way is that some of these scripts, of course, because you don't have the script with you, I haven't shared it yet. So yeah, it would be unreasonable to ask you to follow it unless you type in a super speedy way. But then I think that if you want to follow along for some of the steps, I will share the particular command in the chat box, so that we could try running it for some parts. But then this first part, I would not expect that because it's a bit long and you can try it later. And I guess because this part is actually using the API for Glasgow City Council on the information that they share is, as you can see here very briefly, it would be about, yeah, the movement, yeah, the traffic count, the car parks, the events that might be happening on the highways, the locations, and the variable message system that I was talking about. So you will need an API key, and then we provided the link to get to access that, to sign up for that for this session. But then I believe that it was the website was dead for quite some time. Or I don't know if it was my problem or not, if any of you could actually get a key or could actually sign up. So it doesn't really matter. I will still share the script and you could try it later after you are able to get an account. But yeah, we could see how it looks like. So very first thing is that there would be some libraries that we might need most of the time. Yeah, some libraries like JSONLite, and then something for tidying the tables. And then one particular library that I would be using would be Leaflet, just to show some locations information. And then it looks pretty nice, and HTML tools are also related to that. And then, yeah, you could sign up later. And then these are the, you would be able to, if you get access to the site, you will be able to sign up for a standard account or something like a starter account. And then if you would like a lot of calls over time, like making a request every minute or whatever that you would like, then you will need a business account. But then, yeah, you could do that when you sign. And then, yeah, there are a few URLs, and then, yeah, the key here is actually just entering the key. I didn't show my key, I already entered it. Yeah. So this URL is provided from their website because it's from what I know, it might not be accessible right now, so I would just not show it. But then the flow is a bit like this. You get the key, you get the URL, and then you request that using this command by pasting the key if it is necessary. And then the next part would be more problematic because you will want to see after what you have requested, how it looks like and whether you can just use it directly for your, like, will it look like a very nice data set that you can use right away? So yeah, it works, which is a good sign. And then, okay, so from this request, we can see what we actually have. And then if you look at it, then you can see, okay, this doesn't look like what I was expecting. I was looking for traffic counts. And then if you open it, okay, there are some information about the whole schema. And then you continue with it, then you will start seeing the information that you would want. Because here, let's say this one is a number one, and then you will start seeing the level of the traffic. Yeah, you see the traffic flow of that particular location. So you can see that the site information is here. Each of them is a different site. So this is not tidy at all. And most of the time when it comes to counter locations and the counter information, the data that you try to grab, there is like no simple, as far as I know, most of the time, there are no simple command that you can just use to tidy up this type of data frame that you get right away. So yeah, of course, I would think that it would take too much time for us to do this like this here. But then I guess the point would be that if you click it and you can see that it's kind of at different levels and layers. And then, yeah, I will have to move this a little bit. Yeah. Sorry. Yeah, so that was the request. And then, yeah, we tidied it up. I did some following steps to tidy it up. And then it looks a bit weird, but then the point is that I try to get the movement information from those different layers and put it back into a data frame that I would want it to look. So yeah, these are a bit annoying when you try to do it, but then we will try another one later. But then this is how it looked like at the very beginning. And then, so we could see that this is just requested. So if you click that open, you will see that the time is just now, not far from now. And then if I run these, yeah, then I will be able to get a data frame called movement count, which is the camera and the number of the count, so that I could make use of it more easily. And then let's say if yeah, I will just try it a little bit with the parking data, doing almost the same thing, request it through the URL and then tidying it up. And then, okay, I run it. Then what I'm getting here is that, okay, if we try to open it, and then we would see that, okay, there are the times there. And then you can see the parking locations and also whether there are enough space and then how many of it is occupied. So this sort of information is what we could get from this particular URL. It's a bit annoying because, sorry, the bar keeps blocking me, and try to move it. Yeah, finally. Okay, yeah, so the parking coordinates, they look like this, and then there's the traffic events, and then I could do similar things to it. And also the variable message bots. And you could see that after you request it, is also like a bit of a mess if you try. Okay, this is the message bot, and then this is the thing that we have requested, and we try to press into it, and then we would see something like the information, the status, and then the message that is actually there. So what we have to do is that we have to extract the useful information from this. And then, yeah, that's what we get. It would be after the steps. Then, yeah, because these are actually just columns. So you go into one column and then you go into another column. So I didn't go into big details about this. And then I renamed these columns so that it will look nicer. And then the data frame, if we tidy it up, it will look like, okay, then we have these 5 locations, and then these are the times, and then what their message is just something like this: check your mirrors when moving, blah, 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 and so on. Sometimes there are more interesting information, but then not right now. And these, of course, these message boards also have their location. Then similarly, we could request this. So what I was doing with this is that the next thing would be to combine these message boards with the location, because the message board dataset and the location dataset are in 2 different data frames right now. So if we try to combine that, I have to rearrange a little bit because some of them, they have some extra characters if you click into that particular name of the data frame. So I remove some of them and I try to combine them. And then in the end, what I aim to do is nothing too complicated. It's just that I was trying to put together these data sets and then place them into a nice map. So what I will make use of the leaflet package now, and then I add different markers, such as I supply the location and what kind of label that I am going to use. So yeah, and then I save it as an HTML file. So this is for the parking map and then so on. And I try to choose different icons for that. So I think the most interesting one that I'm going to show is the one where I included the different markers on one map, like for the one with the parking locations, and for the one for the count of traffic, and also the variable message systems. And yeah, it will look something like this. So you have something like, oh, okay, the messages are showing here. And then if you go around, yeah, if you move around, oh, this is way too slow. Yeah, you will see the count on the map along the way, or when you hover over the parking ones, yeah, I got a flag. I didn't find a parking logo. And then you will see that, okay, I'm showing the message whether there would be enough space. So I think that could be something that would be of interest if you want to combine them and show them, or oh, you find that too chaotic, and then you could remove them. You could overlay each one of them, or you could just remove these. And then this is done using the leaflet package. And yeah, Then the next thing would be, I think that we could try something with this one on Brussels traffic count. So let me go to that one. Yeah, this API, because it's open without a key, so I think if you have R with you, you could just try it. Let me share this. There's the chat box. Okay, there you go. Chatbot. Okay, so if you go to this, yeah, this is a site, then you should be able to see that this is actually more complicated than the one that we had for the Glasgow City Council because of what they supplied. We mainly have the vehicle count for that, and this one we have actually way more information. You can read it in details later, but then the point is that you can have this kind of live data about the count and speed and even the occupancy of the road, and then the timestamp and how they get hold of this number. So if you look at here, you get a link with the live stream counts, and also this one, if you click on this one, you will be able to download a CSV with the location of the devices. So that will be useful if you want to put them on a map and if you want to know the exact location of these devices. So let's click on this. And then you see these are when you place a live request, it will mostly look like this for a lot of the cases that you will look into. First of all, you get the request date. This is very updated, which is, they are in Brussels, so that they are 1 hour faster. And of course, it's close to this time. And then you get the device, and you get it for 1 minute, and you get the count, and then the speed and the occupancy and all that. It's not only 1 minute, you get, I think you get 5 minutes, 15 minutes, and so on. But then the main problem would be, of course, to get this and tidy this up in your script. Yeah, so that, first thing first, we just try some of this. And with the URL that we just had, which is this one, you can either save this page or then import it to R, or you can copy this one. I think I just I share that too. Yeah, but then I could do that again. Yeah, I think we can put this. Put this in R and try to import that. Yeah, like, okay, we start from here, URL. So we enter this URL, and then we do this request. Yeah, if you have our studio with you, you could also try it. And then if you run it, then you will see that, okay, we have the whole request for Brussels. Yeah, this is the data that we are looking at. And you can see, okay, that's the device, and then the results involved in this device. And then you have this different type of data that you get. Yeah, you have the count and so on. There's none for this one. Yeah, perhaps I get another one. yeah, then you see these kind of information. That's the type of things that you can extract. Of course, then we will have to go through the annoying steps of requesting them, but then I didn't include them here because I will put them I would not want to like go over them here, and I will include them later when I share the script. But then this is the idea. And then, yeah, as I've said, the location of the counter is actually a CSV file that we could download from the page that I just shared. Then afterwards, I think the next step would be to combine the counter location and also the count. And then you can do different things like putting it on a map or something like that. And then, yeah, of course, that's the map. But then I didn't go into a lot of details, and I yes, this is the Brussels map that you can see. These are the different counter devices that I plot from the previous CSV file. So yeah, you can show more information like the count after you have combined the data set. Again, I will share this information, this script later. Yeah, but then it would be interesting if you really want to try to tackle the area of your interest for traffic count. You will have to try to do that on your own, because I find out that sometimes for different cities or different countries, the way they share or the structure, the scripts would be a bit different, and it's not entirely clear to me if there's a more uniform way of doing it. But then from what I found also on GitHub and other researchers, they do it in this kind of way, one by one. So it's a bit annoying, but then you get what you want. After you set it up, you can you can use it probably for a longer time. So it will be the effort will be worth it. Actually, there's another example for how, and yeah, if you check, this one also doesn't. Yeah, it's super slow. Sorry. Yeah, this one also doesn't require an API key. So you could also try to play with this one. Yeah, you can see that if you do not want to deal with all the messy file that I just showed you, you can also download the CSV. But then you can see that it's like one location by location. So you have tons of files if you have a lot of them. There are quite many of them. And then if you scroll down, then you could see that you go back to the original things. Good data, GeoJSON file or JSON file. Let's see if we could connect this. Yeah, then you get this URL. And then you almost go back to something very similar that you will have to read. Actually, this is the one that I'm referring to. It's a bit slow, sorry. Why is it not moving? Yeah, you go back to something like this. So yeah, again, I would say that this is going to take some time, and yeah, I will share it later how to pass through this, because I don't think we have enough time to do it right away. But then one thing I would like to mention is that these things are usually in real time. And then it's not much use if you just, okay, I get the data at this point of time. So how do you want to use it? I think that I think it would be quite interesting if you want to try it, is that you can connect through a Postgres SQL database, and then you save it every certain number of minutes, and then you build your database with all this kind of information, and then you can schedule your script to be run in a certain time interval, so that you can get this type of information. So yeah, that's what this part is doing. And then, yeah, then if we move on to some sort of the bike share data, we can see that there are many links that some bike companies that I have found over time. And then the thing about bike share is that it's much nicer than what I've shown you about the traffic counters. So if you, let's say for City Bike, okay, for City Bike, let's go to the site of the City Bike. Why can't I click on the link? It doesn't really matter. City Bike here. Yeah, I think I've shown some of this in the previous presentation, where you have all the trip data that you can download as a data dump. And then you have this kind of real-time data in this form. So we try to obtain the real-time data here on the script because, yeah, about the trip data, I will briefly talk about it a bit later using the London share bike. So yeah, again, we do the same thing. We obtain the link. We don't need an API key, so it's relatively simple. We get this, and then so this will be the response of the request would be called City Bike. And then, okay, let's see how City Bike look like. And it's not too bad. You have the station ID, station name, and then the location, the coordinates, and then the status, and so on. So this is a relatively simple. And then if you try to arrange it a little bit from this City Bike data frame, then I use it as I call it the station list. I arrange it a little bit. Then you can see that we could obtain this data frame, which is quite tidy. If you try it like this, I can also put this in the chat if you are trying. Yeah, you can just run this, and then you can check the column names, and then you can see that this is quite neat. Okay, station. Yeah, you can check it. Yeah, you can see that you can have the available docs, and also latitude, longitude, and the status. Yeah, and then also you can get the timestamp. Oh my God, it's from 2016, but then yeah, it's supposed to be much more updated. Yeah, but then most of these different companies, they work in a very similar way, and it's quite straightforward. And then because of they have this common way of putting bike data, usually is not as complicated, and then you could try on your way. And then with Next Bike, that the bike company that's also operating the share bike in Glasgow, we could also obtain it in a very similar way. Like the station data, and then the status, and the number of available bikes. So yeah, this could be done. And then, so yeah, this brings us to very briefly to the last part. Actually, this is a very simplified version of what I intend to share, a very simplified version of the paper that I was talking about earlier, which is something, yeah, that I am trying to share. Wait a second, it's a bit slow. Yes, so that was the analysis, the application that I was talking about a bit earlier in the first half of the session. So the workflow is a bit like this. Of course, I don't expect you to follow it every step right now, but then, yeah, of course, you import the libraries. And then because this is a data set which are with the detail trip data, so that you can see it looks like this. You have the start time, end time, duration, and then also the station number, and you can do all sorts of things, including arranging these numbers in terms of stations. So the idea is that we could also, because when I was talking about the paper, you remember that we have this suspension period and so on, so that we could introduce some dummy variables to to mark the period during the suspension and after the suspension and so on, and also introduce the treatment group and the control group for the different stations. So yeah, the workflow is something like this, where you introduce the buffer and then you introduce the dummy variables for the treatment and control station, the suspension period, and also clean up the data about longer trips that you might want to drop, or trips that do not include in your analysis, such as having the same origin and destination. And then, so we also include weather data. So it also took some time to just putting the weather data by day and arranging them such that it could be combined with the panel data set and also the public holidays and so on. So if we go back to the R script, of course, because I don't have, I could not share that particular data set. So that's why I think that we could do it like this. You could try, okay, if you want to try, you can import a few libraries. You might not need all of them. This is just a start. I will share the whole thing later. And because the London one, if you try to get access to the London bike share data, it's actually pretty comprehensive. Let me try to get to it. Yeah, here. Yeah, if you go there, yeah, you should be able to see this bucket loading thing. Yeah, because I was just creating the example. I got a bit lazy, and then I saw the zip file for 2015. So I just downloaded and then read it. Yeah, it's somewhere. But then you can see that they have data for every single week. And then if you scroll down, you can see the older data in a zip file. So that if you just want to try something to see if it works, just download one of these. And then what I did is that I set up a folder to house this part. And then with this folder, I create a file list, and then I read all these files. Because if you actually look at the folder, if for the whole 2015, you have one file for each week. And then you will end up getting a pretty big data set. So yeah, let's do this. It might take some time. But yeah, we can try. Yeah, after you download it, you can try it. But then I'll just put this here in case you would want to follow right now. If you have a fast enough connection. Yeah, of course, this is just my folder path. You will have to change it. And yeah, and then if you follow this, then it will be reading these files. And it will be called London Bike Share. Yeah, if we click into it, you can see that it's really pretty huge. I think it is almost 10 million, right? If I read correctly. Yeah, while the one for Nextbike is like 10% of this size, I think, or even less. Yeah, so it will be more, yeah, it will be more effective if you can just read this using F-read, I suppose, if you're familiar with it. And then about the location of the station, then it gets more interesting because it actually took me some time to dig it out. And surprisingly, it's actually not from direct download. It's more like from freedom of information request that people were requesting the location of the stations. That I found the file of the location of stations around that time, then I read it. Yeah, then I try to, yeah, because it's a bit messy. If you can see, I will just show it very briefly. You can see that the station name here, you have the station name, and then you have some sort of the local area in your trip data set. But then if you look at the station data set, do I have it? Yeah, you can see that is slightly different. So what I was doing here is just to rename them and try to remove the part of the station name so that they could match. I try to extract the part before the comma. Yeah, so afterwards, then you get something that is quite neat. Then actually you could try to arrange it. You could try to combine them together. And here, this is just something simple, because if you look back to your station, to your trip data set, you can see that these names, they are all separated by spaces, and sometimes spaces could cause problem. So I replace them by dots. So yeah, I mean, it's usually this is up to you to see what you want to do with them, or you can replace it with something else. And then yeah, the next one would be just to merge them so that we get a different data frame that we could use. And yeah, let's say I would need the location of these stations to plot them on a map or something. So that would be pretty useful. But then the merging will take some time, so I will not run it. I think it's low enough. And then afterwards, then I would like to arrange the number of trips by day. Actually, this is just to show that sometimes we might want to do something like plotting the number of trips by day, or we might want to plot the trip duration by day. And then if you think back, this is actually, if you combine this data set, this is actually something that you find a lot in places like Kaggle, where you can find the number of trips data set combined with weather data set, where people are using these data sets to run their algorithm. So my point is that if you get the more complicated data done, then you could easily reduce it back to something that you could use very easily. Because, yeah, here I didn't include everything, but then the next step that I would share would be something like, after arranging them by day, I will combine it. Actually, I find this quite interesting because I find a daily restriction of COVID lockdown restrictions in London. So potentially, if I were using the 2020 and 2021 data set, then I could easily run some analysis after I combine these for daily number of trips, and then I also get the station level data, and also every day how the restrictions look like. This is very interesting. You can get it from the data store later, but then it's also on the Department for Transport site. The reason that I highlight this is that you can see, okay, you have the school closure dummy, pub closure dummy, shop close dummy, and then by date. And then that's a pretty useful information if you try to run it and relate it to other data sets. All you need is the date to combine them. And then, yeah, I also mentioned that in terms of the station, in terms of what you have between the treatment station, let's say you can identify that some station you have an hypothesis saying that some stations might be more affected by these measures than the others. Then you can carry out the same type of analysis that I was talking about earlier on, similar to that research paper that I was talking about. Yeah, so this is the idea. Although I didn't show every step in the complete code for now, but I'm going to share it, and then I hope that you can see how, after you get some of these data, how you can proceed to get more from them by developing a data set and a workflow that goes from there. And there are numerous research possibilities for that as a citizen, or even as perhaps a student, to look through this kind of thing, or even as a researcher, you might want to explore your research questions from these type of data. So yes, this is it for now. Yeah, I understand that I didn't really have much time to cover all the steps, so you might find it a bit puzzling and a bit chaotic at times, but I will try to share the materials and the links here, so you could try it, and you could try it later. So yeah, this is it. Thanks.